Welcome back to the channel. This is going to be a little update on making three-phase voltage measurements on the MTR105 using my little frequency inverter. A couple of additions that have been made to this set of tests. I'm going to run the MTR105 in parallel with the UT233 clamp meter to see how that performs, and I've also assembled a sinusoidal filter to put onto the output of the frequency inverter. First off, I'm just going to have a little recap and run the inverter without anything on the output, just the two instruments, and that will show how the MTR105 performed directly against the UT233, and then I'll do a second set of tests with the sinusoidal filter connected to the output feeding into these two instruments. So hopefully you can see the UT and the MTR105 there. You can see that the MTR105 is bouncing around quite badly. Interestingly enough, you actually see the UT is very stable on 26 to about 26.5 volts. And that is where you would expect it to be for the 10 Hz signal. The other thing that you see happening there is the MTR105 keeps coming back with this error when you've got dodgy frequency on it. It doesn't seem to like it at all. But we'll knock him off and put him back on, and we'll try and set him up to 20 Hz. So that's smack on 20 Hz there. Three phase, again quite messy. We'll wind him up to 25 is halfway, isn't it? Take a bit further to 30. To 40. MTR's conked out again. And wind him up to maximum. Okay, so you can see we're running there on 50 Hz output. You can actually see the UT233 is very stable. Certainly a lot more stable than the MTR105. That's quite an interesting result, not what I was expecting at all. So yeah, +1 for the UT in that respect. Okay, so that's the initial test done with the inverter open circuit. I'll switch off now and I'll wire in a sinusoidal filter onto the output of the frequency inverter and see if that improves the situation with the MTR105. Okay, just to put the 2 meters out of the way, what you can see here is my inverter. I've actually wired the output of this now onto a choke and a set of capacitors at the back there. I'll put a better picture up on the screen. And that's forming a sinusoidal filter on the output of this inverter now. The motor over here I am still leaving disconnected at this moment in time, and we'll take some measurements and see what we come back with this time around. Okay, so we'll set up on the 2 instruments again. Put the light on you. So we're on 10 now. So you can actually see the MTR is actually quite a bit more stable now. All he says. But yeah, that was short-lived, wasn't it? Never mind, let's go up to 20. So now we're on 20. The MTR is quite a bit stable, and you see the actual rotation coming on every now and again. It's gone off there. We're at 20 Hz, so 90 volts face to phase is about right. So it looks like the sinusoidal filter is working. Let's see if we can get up to 25. It's 25. Up to 30. Looks like the rotation is pretty much on now. I'm not coming off. Go up to 40. And finally up to 50. (224, 223). Pretty stable there. So my sinusoidal filter appears to be working quite well. Okay, so that kind of proves the point that the MTR105 doesn't like the square wave output of the frequency inverter, but the UT seems to be quite happy with or without a sinusoidal filter. But the sinusoidal filter has definitely helped out on the MTR105. So that's testing complete. Rather an interesting set of results from the instruments there. Pretty good performance from the UT233, unlike the MTR105 that needs the sinusoidal filter on the inverter to get that running. The UT can operate with or without the filter. So it's obviously got a bit of different electronics or firmware inside this that can cater for the output of a frequency inverter. The tests though do show that the MTR105 is capable of measuring the output of an inverter if you have a sinusoidal filter on the output. So if you've got a high spec frequency inverter with a sinusoidal filter on the output, it looks like you can use the MTR105 with it, and you'll get some good readings. So the readings that I've taken with this, they have been sent back to Megger for comment. I've not really had too much back from Megger with regard to that aspect. I'll probably send them some results from this to show them what readings I got with the filter in circuit and that it was working. So in my experience of this kind of a situation with manufacturers, they will work on how many times somebody reports a fault to them. So if this fault of not being able to measure the output of the inverter is reported by a lot of people, then they're more likely to address it. On top of that, if they can address it through a firmware upgrade, then that makes life much easier and they're much more likely to make the modification to that. And obviously then that modification can be applied directly to the unit that you have. If few people write in, there's not many, if it's just me that pointed this out to Megger, then Megger are highly unlikely to address it, I would have thought. Certainly that's been my experience with other manufacturers of instrumentation when you've reported issues to them. It's a bit sort of like, well, you're the only one who's raised this issue. It's not going to get addressed. We've got other issues to address with it. And of course, if it's a hardware issue needed to resolve it, then that's a lot less likely to be catered for. And if it was, it wouldn't correct this specific unit of mine unless I could arrange to send that back to the company and have that modification made to it, either through free of charge or a cost, however they want to work it. Now the sinusoidal filter I built up for the previous test has been sized to run the motor, because the motor will be in series with the choke here. The choke has to be able to handle an amp or so, and so that gives it a lower inductance value, which means I have to increase the capacitance size to get the kind of low pass frequency I want. That's obviously not much use for taking around with you to work on other inverters. So I have built up this little box here which has another low pass filter in it, and the components have been kind of swapped around. I've got a higher value inductance, and that allows me to decrease the value of the capacitance in there, and I can size it all in this. And what I can then do is push this into the top of the meter there, and then I can plug in my leads into this, switch them on to volts. So hopefully you can see him there. We'll flip him over to 3-phase. We'll turn him on. Okay, so set up there. Take this up to 10. Says. 10 there, so I'll let him settle. 48 volts. Yeah, still a little bit of instability in there. Not got rotation either, and I've not got frequency value. Take it up to 20. That's 20. And now we've got a frequency there, but it's bouncing around an awful lot. Voltage wise, we're at 92-ish. Reasonably stable. It's got an unstable frequency. 25. Up to 30. Oh, that's 40 there. Okay, so at 40 we're quite stable on the frequency, 40.3 Hertz, 182 volts. Wind them up to 50. So you can see there, stable 50.2 Hertz and 224 volts, and I've got my phasor rotation there as well. That's one solution. With a bit of tinkering around, you can make this MTR105 work on a frequency inverter. I'm sure there are plenty of people out there that could redesign this little filter much better than I can. I was limited a little bit to the size of the box. I wanted to try and keep the box fairly small because it plugs right into the top, but that in turn reduces the size of the components. So if you had a 3D printer and you made this a wider box, you'd be able to fit better sized capacitors in there for a much better voltage rating as well. But it's proved its point. You can do it. Whether Megger will resolve it or not, I do not know. I've sent the data to them and we'll see what comes out of that. That's it for this video. Quite surprising that the UT233 can outperform the MTR105. But there you go. Hope you found the video useful. If you have, please give it a like, and I'll see you again in the next video.